Hello, welcome to Anybody Can Learn. Today we will start practice for quiz 2. So let's solve some questions. Consider the following data set with the 4 features F1, F2, F3 and F4 and 3 labels y is equal to 0, -1, +1. Assume the features to be binary. Answer the given sub-questions under the naive-bayes assumptions. So these are the samples and the features F1, F2, F3, F4, and this is a class Y. So this is the information given to us. Sample 1 has a class 0 and the features are 1, 0, 1, 1, and sample 2 has a features 1, 1, 0, 0 and its class is 0. Sample 3 has a feature 0, 0, 1, 0 and class 0. Sample 4 has features 1, 1, 1, 0 and class +1. Sample 5 has the features 0, 1, 0, 0 and class +1. Sample 6 has a feature 1, 0, 1, 0 and class +1. Sample 7 has a feature 0, 0, 0, 1 and class -1, and sample 8 has feature 0, 1, 1, 1 and class -1. So features to be the binary means each feature has either value 1 or 0. So the given data contain 3 samples that have the class 0, 3 samples that have the class +1 and 2 samples that have the class -1. So the sub question is find the maximum likelihood estimate P1 hat, P2 hat and P3 hat of P of y is equal to 0, P of y is equal to +1 and P of y is equal to -1 respectively. So understand the given data. We have a data set with the 4 binary features F1, F2, F3, F4 are the features, and binary means each feature have the value either 0 or +1s. So such 8 data sets we have given and each sample has a features F1, F2, F3, F4 with their values either 0 or 1, and they all have a labels y, and y is a set of 0, +1, -1s. So total training samples given to us capital N is equal to 8. So binary means 2 possible values. So feature has only 2 possible values 0 and 1. Now calculate the prior probabilities. So prior, that is P of y is equal to C, is calculated by the formula samples in a class C divided by total number of samples. So the total number of samples are capital N is equal to 8, that is given in our questions. So now count the class 0 samples. So just now we see that our data sample has 3 samples that belong to the class 0. So total number of samples that have the class 0 is 3. So probability of y is equal to 0 is 3 divided by 8. 3 because total number of samples that belongs to class 0 is 3 and 8 is because total number of the samples, that is 8. Similarly, calculate the probability for prior probability for class 1 and +1 and -1. So count the class for +1. So sample 4, 5, 6 belongs to the class +1. Therefore, the total number of samples that belong to class 1 is 3. So probability of y is equal to +1 is equal to 3 divided by 8. Now count the class -1. Sample 7 and 8 belongs to class -1. Therefore total number of samples that belong to class -1 are 2. Therefore probability of y is equal to -1 is 2 by 8, so it is 1 by 4. So now check whether we calculated it correctly or not. So 3 by 8 plus 3 by 8 plus 2 by 8 is 1, so we calculated it correctly. So what class would x test is equal to 1, 0, 1, 1 transpose belongs to? Assume that no Laplacian smoothing has been done. So naive-Bayes classification given to our test point is input is 1 0 1 1, and this means the feature f1 is 1, f2 is 0, f3 is 1, f4 is 1, and the task is decide whether these test points belong to class 0 or class 1 or class -1. That means y is equal to 0 or y is equal to +1 or y is equal to -1 for this test point. So naive-Bayes formula is probability of y given x is proportional to probability of y multiplied by probability of f1 given y multiplied by probability of f2 given y multiplied by probability of f3 given y multiplied by probability f4 given y. So score of y is pure multiplied by product of conditional probability. So this is the product of conditional probability, and rule is choose the class with the highest score. So we will choose a class which has highest score. No Laplace smoothing means question specifically says this because if a feature value never occurs for a class, then its probability become exactly 0. For example, if we never see f4 is equal to 1 in a class +1, then probability of f4 is equal to 1 given y is equal to +1 is 0. Because naive-Bayes multiplies everything, score become 0 immediately. So score is probability of y multiplied by probability of f1 multiplied by probability of f2 multiplied by probability of the f3 multiplied by 0. So this 0 come because f4 is never f4 is equal to 1 is never seen. Now calculate the score for class y is equal to 0. So total class 0 samples are 3. So sample 1, 2, 3 that belongs to class 0, therefore total number of the samples that belongs to class 0 is 3. So now calculate the probability of f1 is equal to 1 given 0 is probability of f1 is 1 given 0 is 2. 2 divided by 3. 3 is total number of the samples that have class 0, that's why it's 3, and 2 because 1 occurs in a 2 sample, so it is 2 by 3. Similarly, probability of f2 is equal to 0 given 0 is f2 is this, f2 is 0, so 0 occurs in a first sample and third sample, so it occurs for 2 times, so it is 2 divided by 3, 3 because total number of the samples are 3. Similarly, probability of f3 is equal to 1 given 0, f3 1 occur in 2 samples, first sample and third sample, therefore 2 divided by 3. Similarly, f4 is equal to 1 given 0, 1 because a1 occurs only in a first sample, therefore its count is 1, so it is 1 divided by 3. So find multiplication. Score of class 0 is equal to prior multiplied by probabilities. Our prior is 3 by 8. So 3 by 8 because the number of the samples that belongs to class 0 is 3 and the total samples given to our data set is 8. So it is 3 by 8. So it is 3 by 8 multiplied by 2 by 3 multiplied by 2 by 3 multiplied by 2 by 3 multiplied by 1 by 3. So our final score is 1 by 27. So calculate the score for class y is equal to +1. So total class +1 samples are 3, 4, 5, 6 samples belongs to the class 1. Therefore, total number of samples that belongs to class 1 is 3. So calculate the probability of F1 given is equal to 1 given class 1. So F1 is occur 2 times, 1 occur 2 times, 4 in 4 sample and 6 samples. So its count is 2. So it is 2 by 3. Probability of F2 is equal to 0 given class 1. So F2 is equal to 0 is 0 occurs only for 1 time. So it is 1 by 3. Similarly, probability of the F3 is equal to 1 given given class 1. So it is a 1 occur for 2 times, 4th and 6th sample. So it is a 2 by 3. So probability of the F4 is equal to 1 given plus 1. So in F4 the 1 never occurs. Therefore it is 0 divided by 3. So now complete score plus 1 score is score plus 1 is equal to prior is a 3 by 8 multiplied by probability is 2 by 3 multiplied by 1 by 3 multiplied by 2 by 3 multiplied by 0. So our final score of for class plus 1 is 0. Now calculate the score for class y is equal to minus 1. So total class minus 1 samples are 2. In our original data, number of the samples that belongs to class minus 1 are is 2. Therefore, the total number of the class is 2. Now check the probability of the F1 is equal to 1 given minus 1. So F1 is 1, F1 never occur in the F1, therefore its probability is 0 by 2, that means 0. Other probability is probability of the F2 is equal to 0 given minus 1 is 1 by 2 because 0 occurs only in the 7 samples. So it is 1 by 2. Probability of the F3 is equal to 1 given minus 1. F3 1 occur only in the 8 sample. So it is a 1 by 2. Probability of the F4 is equal to 1 given minus 1 is 2 by 2. So 2 by 2 means 1 because 1 occur in the sample 7 as well as in 8. So it is a 2 by 2. So final score for minus 1 is 1 by 4, 4 multiplied by 0 multiplied by 1 by 2 multiplied by 1 by 2 into 1. 1 by 4 is a pure because 2 occurs in our original data of 8 samples. So it is a 2 by 8. 2 by 8 means 1 by 4. So score for minus 1 is 0. Now we have obtained the final score. Score for class 0 is 1 by 27. Score for plus 1 class is 0. Score for minus 1 is 0. The largest value is 1 by 27. So therefore y hat is 0 because our test samples is classified as class 0. Let us see another example. Consider the following data set. Samples 1, x1 is 1 and x2 is 0 and its label is 2. For sample 2, x1 is 0, x2 is 1 and its sample is 3. For sample 3, x1 is 1, x2 is 1 and sample 4. For sample 4, x1 is 2, x2 is 1 and its label is 6. Suppose we fit a linear regression model of the form y hat is equal to w1x1 plus w2x2. Compute the mean square error for the training data. Enter the answer correct to the 2 decimal places. The linear regression formula given to us is y hat is equal to w1x1 plus w2x2, where y hat is the predicted value of y, w1 is the weight or coefficient associated with the x1, W2 is the weight or coefficient associated with the x2. Sometimes the model look y hat is equal to w1x1 plus w2x2 plus b, but our question has not given us the intercept b, so we will not add an intercept. So finding the weights. So how do we find the w1 and w2? We can use the normal equation. This is an important formula for ordinary least square linear regression, and the formula is w is equal to inverse of x transpose x multiplied by x transpose y, where W is the weight vector containing our weights. So W is a column vector with entries W1 and W2. So the matrix X contain all our input features x1, x2. So it is a 1, 0, 0, 1, 1, 1 and 2, 1 matrix. And Y contain all the output values. So output values is 2, 3, 4 and 6. Now calculate the X transpose X. So X transpose means 1, 0, 1, 2 and 0, 1, 1, 1. Transpose means convert the rows into columns and columns into the rows. So this column get converted into the row. So 1, 0, 1, 2 column become 1, 0, 1, 2 row in X transpose. Now calculate X transpose X. X transpose X means 1 multiplied by 1 plus 0 multiplied by 0 plus 1 multiplied by 1, so plus 2 multiplied by 2, so it is a 1 into 1 is 1 plus 1 into 1 is 1 and plus 2 into 2 is 4, so it is a 6. So it is a comes a 6. Now 1 multiplied by 0 plus 0 multiplied by 1 plus 1 multiplied by 1 plus 2 multiplied by 1, so it is a 3. So our entry is 3. Now calculate the second row of the X transpose X. 0 multiplied by 1 plus 1 multiplied by 0 plus 1 multiplied by 1 plus 1 multiplied by 2, so it is a 3. So our second row first column is 3. Now calculate for the second row second column. 0 multiplied by 0 plus 1 multiplied by 1, so plus 1 multiplied by 1 plus 1 multiplied by 1, so it is a 3. So our entry is 3. So our X transpose X is 6333. Now calculate the X transpose Y. So X transpose Y, first row and first column entry is 1 multiplied by 2 plus 0 multiplied by 3 plus 1 multiplied by 4 plus 2 multiplied by 6. So it is a 2 plus 0 plus 4 plus 12 is 18. So it is 18. Now calculate the second row and the second entry of the first column. So it is 0 multiplied by 2 plus 1 multiplied by 3 plus 1 multiplied by 4 plus 1 multiplied by 6. It is 0 plus 3 plus 4 plus 16 is 13. So X transpose Y is a column vector with entries 18 and 13. Now calculate the inverse of the matrix X transpose X. We know that if A is a A, B, C, D matrix, then its inverse is calculated by the formula A divided by A into D minus B into C multiplied by matrix D minus B minus C A. So in our X transpose X, we have A as a 6, B as a 3 and C as a 3, D is a 3. So AD minus BC is AD is a 6 into 3 minus BC is a 3 minus 3 into 3. So 6 into 3 is 18 and 3 into 3 is 9. So 18 minus 9 is 9. Now so we will get inverse of X transpose X as 1 upon 9 multiplied by matrix 3 minus 3 minus 3 6. So this 3 means D. So D is this, and this minus 3 means minus B, so minus of 3, and this minus 3 means minus of C, so it is minus 3, and this A 6 means A, so it is 6. Now substitute everything into our inverse of X transpose X multiplied by X transpose Y, that is our weight vector formula. So it is W is equal to 1 upon 9 multiplied by 3 minus 3 minus 3 6. This is just now we calculated inverse of X transpose X, and X transpose Y calculated as a column vector 18 and 13. So 3 multiplied by 18 plus minus 3 multiplied by minus 3 multiplied by 13. So it is 54 minus 39, so it is a 15. So our W1 is 15 divided by 9, so it is 5 by 3. So now calculate the W2. So W2 is calculated by minus 3 multiplied by 18 plus 6 multiplied by 13, so it is a minus 20 54 plus 78, that is 24. So W2 is a 24 divided by 9, 9 means 8 by 3. So W1 is 5 by 3 and W2 is 8 by 3. So our linear equation is y hat is equal to 5 by 3 times x1 plus 8 by 3 times x2. Let us calculate the prediction for sample 1. Our sample 1 has x1 as a 1 and x2 as a 0. So substitute this value in our y hat formula. So y hat 1 is equal to 5 by 3 multiplied by 1 plus 8 by 3 multiplied by 0. So it is a 5 by 3 y hat. So y hat is approximately equal to 1.67. So actual value of y1 is a 2. Similarly, calculate the sample for 2, y hat for the 2. So our sample 2 has x1 0 and the x2 has a 1. So substitute this value in our y hat formula. So y 5 by 3 multiplied by 0 plus 8 by 3 multiplied by 1. So it is a 8 by 3. 8 by 3 means 2.67 approximately. So y hat is approximately equal to 2, but the actual given is 3. Similarly, calculate for it for sample 3. Sample 3 has a x1 as a 1 and x2 as a 1. So substitute these in our y hat formula. 5 by 3 multiplied by 1 plus 8 by 3 multiplied by 1. So it is a 13 divided by 3. So y hat is 4.33, but actually given to us is a 4. Similarly, so calculate for sample 4. X1 is 2 and x2 is 1. So after substitution it becomes 5 by 3 multiplied by 2 plus 8 by 3 multiplied by 1. So it is a 10 by 3 plus 8 by 3, that is 18.8 by 3. So 8 by 3 is a 6 and we predict it as a 6, but our actual value given to us is a 6. So let's summarize everything in our table. So sample 1 actual value given is 2, our prediction value is 1.67. Sample 2 actual y is given to 3 and y hat is given as a calculated as a 2.67, and sample 3 actual value of y is 4 and calculated as 13.3, that is 4.33, and for 4 sample actual is 6 and predicted value is 6. So let's calculate the error. Error is calculated by the formula yi minus y hat, where yi is the actual value and y hat is the predicted output. So calculate for the sample 1. Sample 1 actual given is 2, predicted as a 5 by 3. So it is a 2 minus 5 by 3, that is 1 by 3. Calculate the error for sample 2. Sample 2 actual value is given is 3 and calculated predicted value is 8 by 3. So it is a 3 minus 8 by 3, that comes to be the 1 by 3. And calculate the value for sample 3. So sample 3 actual value given is 4 and predicted it as a 13 by 3. So it is a 4 minus 13 by 3. So it comes to be minus 1 by 3. For calculate the error for sample 4. Sample 4 actual value given is 6 and predicted value is also 6. So it is a 6 minus 6 means 0. Now why to square the errors? Notice that one error is a negative, that is minus 1 by 3. If we simply add them, it would not properly measure the total magnitude of errors. Therefore, we square each error. So sample 1 error after square it become 1 by 9. Sample 2 square, sample 2 error after squaring it become 1 by 9, and sample 3 square, sample 3 error after squaring it become 1 by 9, and sample 4 square after squaring it become 0. So square error is 1 by 9, 1 by 9, 1 by 9 and 0. So calculate the SAC. SAC means sum of square error. Before calculating the mean square error, we first calculate the sum square error. In simple words, sum square error sums every error and add them. So SSE is equal to summation of yi minus y hat square. So 1 by 9 plus 1 by 9 plus 1 by 9 plus 0 is equal to 3 by 9. So SSE, that is sum square error, is 1 by 3. Now calculate the MSE. MSE is the average of all square error. So MSE is equal to SSE divided by small n. Small n is the total number of the samples given to us. And just now we calculated SSE as 1 by 3 and sample given to us is 4. So it is 1 by 3 divided by 4. That means 1 by 3 multiplied by 1 by 4. So it is 1 by 12. So 1 by 12 means 0.083333. So our final answer after correcting it to two decimal places is 0.08. So MSE is 0.08. Let's see some important formula. The y hat is equal to w1x1 plus w2x2, that is given to our equation. Normal equation for w is inverse of x transpose x multiplied by x transpose y, and prediction is y hat I is equal to w1 x1 xi plus w2 xi, and error is calculated by y minus y hat I. Y is the actual value and y hat is a predicted value. Square error is ei square is equal to yi minus y hat square whole square. Sum square is summation from 1 to n yi minus yi hat whole square. The MSE is a SSE divided by small n, or it is also calculated by 1 upon n summation from 1 to n yi minus yi hat whole square. Thank you.